This is the video introduction to experiment 10 in the Mr. Circuit 30-in-1 lab. This experiment will demonstrate how a transistor oscillator works. Here is the page for experiment 10 from your lab manual. Notice that there are three subtitles: the purpose, the procedure, and the results. The purpose of this experiment is to learn about audio oscillators and then build and observe a two-transistor oscillator in action using NPN and PNP bipolar transistors. The procedure would be using the parts from your Mr. Circuit lab, build the circuit on your solderless circuit board as shown in the pictorial diagram. Compare the pictorial to the schematic diagram. Does the pictorial follow the schematic diagram? Results. An audio oscillator is a device that generates a frequency in the audio range. An electronic oscillator does this by using electronic components like transistors, etc. The frequency of an oscillator is how many times per second that a complete cycle of change occurs. A speaker is used to turn these oscillations into sound waves in the audio range. Audio oscillations are those that the ear can hear. The human ear can usually hear oscillations from as few as 10 cycles per second up to 16,000 cycles per second. This oscillator has two transistors that are connected together with resistors and capacitors that make the transistors turn on and off at a frequency that you can hear out of the speaker. The frequency of this oscillator is controlled by the values of resistor R1 and capacitor C1. They are set to give you about 500 cycles per second, which is sometimes referred to as 500 hertz. By increasing the value of either one or both of these capacitor or resistor, you will lower the frequency of the oscillator, and vice versa. Here you see I have wired up experiment 10 in Mr. Circuit Lab 1. This will demonstrate how two transistors can be used to make an oscillator. First we have the NPN 3904, then we have the PNP 3906. Here you have a 0.1 disc capacitor, you have 1, 2, 3 resistors, and 1, 2, 3, 4, 5 jumper wires, in addition to the battery snap. Notice that the pictorial diagram shows the speaker connected to a 10 ohm resistor through a jumper wire back to the black. Now if you compare that to the schematic diagram, you'll notice that you have the speaker and it's connected to a 10 ohm resistor and connected all the way back to the negative of the battery. So in this case, the pictorial diagram matches up with the schematic diagram. It should be that way for every component in the circuit. If you assemble this circuit carefully, it should work. In this experiment, the two transistors are turning on and off, which then in turn turns the speaker on and off at a certain frequency. You should be able to hear that tone of that frequency from the speaker. Let's try it to see if it works. Do you hear it? That is a tone of approximately 500 cycles per second, or 500 hertz. All right, it's your turn. Gather together the correct components and wire up this experiment on your solderless circuit board, and let's see if you can make it work like I did.